Hi, I am Alexis, the current president of X Urc Robotics.
And my name is Monica, the current vice president. And welcome to X Urc Robotics.
Roberto is a Mars rover that consists of 6 wheels and a 6 DOF robotic arm, which makes it possible to deliver a wide variety of objects, perform equipment servicing tasks, and carry out scientific procedures while having a strong perception system for autonomous navigation. The software architecture used for the main transversal control is implemented in the ROS Melodic and the ROS Noetic embedded in Ubuntu 18.04 and Ubuntu 20.04 respectively. We used an NVIDIA Jetson Xavier as the main control unit, which is connected to our motherboard that commands every model throughout a microcontroller on an internal network provided by the setup of Ubiquiti antennas. We implemented several manufacturing technologies such as 3D printing, water jet cutting, and CNC machining in order to develop accurately the physical parts of each task. The implementation of the control system in a motherboard allows to reduce the space required to implement the different models, which are related to the mechanical part. With the help of simulations from past years, we can precisely determine the robot's arm position, direction, and trajectory by using vision, direct, and inverse connects. With this, we solved past problems that we had with the depth of field perception. Based upon previous robot designs, a new gripper design was chosen that is similar to the one currently being used. This new gripper will have a more direct approach that will improve its mobility and reduce its weight. With this gripper and the robotic arm, we expect that the rover will be able to lift more than 8 kilograms. Because of its simplicity, we chose a shovel attached at the end of the robotic arm as the best way of collecting a sample. We can inspect the soil with a microscope of changing lenses. It will help us analyze the geological composition of the soil before taking a sample. This in order to identify minerals, rocky structures, and components needed for organic life. The sample will be collected and then dispatched to the centrifuge and the spectrophotometer, both in the back of the rover. The viability of soil to grow any life form will be determined through the analysis of pH, nitrogen, phosphorus, and potassium contents by using a soil testing kit. To test the presence of an organism in the sample, proteins will be analyzed as biosignatures through the Bradford protein test, which has a greater change of color in the dissolution as the concentration of proteins increases. A two-phase algorithm for autonomous navigation is being developed. In the first phase, the rover is able to navigate from its current position to a desired GPS coordinate. The second phase will be activated when the rover is not able to find the Aruco code and will therefore perform a sweep of its surroundings in order to find the desired target. Regardless of where the algorithm is at, the rover's top priority is its own safety. So, if it encounters an obstacle or a dangerous terrain, it will avoid it. Similarly, when an Aruco code is detected, it will suspend GPS navigation and approach the target until it's less than 50 centimeters away.